After I finished the construction of my HF Mark IV transceiver, I had quite a few components left over. So I thought I'd knock up another transceiver with maybe less bands, just to use up some of those components, and also it might be useful just to take away, for example, when camping. So using most of the design from the previous transceiver, I made up some circuit boards, and here I've laid them out on a prototype. Now I've tested all the circuit boards. This is basically the complete receiver, and they all seem to work quite well. So I'm now at the stage where I need to mount all these components inside some sort of case. Just as an example of how I go about designing the case, I normally start with the front panel and lay out all of my controls. I tend to like the tuning control in the middle of the case and a rather largish knob. To the right of the tuning control, I tend to put the more often used controls such as the volume control, and then the RF gain, IF gain, and the switches. To the left of the knob, I tend to put the less used controls such as the mic gain, drive, etc. In the next step, what I do is I take a copy of the printed circuit boards and I lay them out in an order that I think might suit the particular design. For example, here I have the boards laid out on some graph paper in what might be the size of the case. So here I have the RF preamplifiers. This particular rig has 3 bands, 80, 40 and 20. The RF signal will come in this direction. The next module is the receive mixer. In this particular design it's a H mixer, so I want to try it out. And that's followed by the crystal filter and then the intermediate frequency amplifier. You'll notice they're all in a row and they're located in that part of the case. Up the front of the case we have a couple of components. We have the TFT meter, which is going to sit here, and the BFO system. So here's a view of the TFT meter with a bit of power on it, and that's going to sit at the front on the left. And we have the VFO, which is assembled inside this shielded container with the tuning control and a number of buttons, and on the back various relays for switching the various functions in and out. So those two items will fit on this drawing, one there and one there. So the circuit boards have to fit behind the VFO and behind the TFT meter on that layer. That is the top layer. And it's also very important at this stage to point out that most of these circuit boards have adjustments on them, and you need to be able to get to those adjustments once they're in the box so that you can align the radio up. The preamplifiers have tuned circuits with small tuning capacitors and so on. The other thing is you also need to make sure that the adjustment direction is from the vertical position, so the trimmers and all those need to be vertically adjusted. If you have horizontal ones, you won't be able to get to some of the adjustments. So that's one consideration. So the boards need to be laid flat and in such a way that you can get to the various components and adjust anything that you need to adjust. So that was the layout for the top half of the case. Now in the bottom half of the case you can also put some circuit boards in upside down, and you might notice they're also in a row. I intend to use mounting rails, that is some aluminium bars, to take these boards so that if I need to get to the bottom of any of the boards, I can remove a board on the other side and get to the bottom. I also need to be able to probe some of these boards so that I can find out if they're working correctly. On the bottom of the case we have located the modules in such a position that it suits the top of the case. For example, the output of the IF amplifier needs to go into 2 directions. First, the AGC module and the product detector. The output of the product detector will feed the speaker amplifier. The product detector requires the BFO, which is located here. The other item that requires the BFO is the double sideband modulator, and so what we've located here is the microphone amplifier, the double sideband modulator. Now the double sideband modulator will feed the crystal filters, and the output of the crystal filters at 9 meg will be single sideband. That single sideband signal now needs to be mixed to one of the 3 amateur bands. So over here we have the transmit mixer. Don't forget the VFO is sitting here, and the VFO will hit the transmit mixer as well as the receive mixer, which is on the other side of this chassis. What we call, this is the bottom, the other side is the top. The BFO will need some pretty good shielding. We don't want any of the 9 meg BFO signals getting into the front end of the IF strip on the other side, or parts of the circuit where it's not wanted. It really needs to just go to the product detector and to the balance modulator. So I've left a bit of room around that particular module so I can put it inside a metal case. So that's most of the modules, including some of the transmit modules. Now on the back of the case I like to put the higher powered RF stuff, and that's on the outside of the case so that it's shielded and away from the more sensitive front end circuits for transmit, for example the microphone amplifier. So on the back we'll have the 10 watt driver, the 100 watt PA, the low pass filters, and then a space for power input connectors, antenna, PTT line, ALC output, and so on, external speaker and Morse key. So we need a box roughly that looks like this. It's about 130 millimeters high, and I've worked out it's about 270 millimeters deep. Now it's quite difficult to purchase a case that size, so I've decided to make it using pieces of aluminium angle and flat aluminium sheet. So at this stage we do some rough drawings. This is a drawing which represents the aluminium structure. It's basically a cage with some aluminium bar strengthening it, and also some aluminium bar for supporting the modules. Now I do want to be able to get to the bottom of all the circuit boards, so the boards will be mounted on bars so that if you remove a board from the other side of the case you can get to the bottom of the board underneath. There will probably be some shielding between which also have to be removed. Having done that, we then start to look at the detail, and I intend to use aluminium angle, which is quite cheap to purchase, and we start to look at details like how we're going to connect the corners up, how we're going to do the front panel, and so on. The front panel will need some labels printed, and in this particular design I've decided to have 2 labels around that size for the right hand side and a label around that size for the left hand side. The top section will be some aluminium escutcheons. They'll probably be painted black, and they'll be 1/4 inch aluminium thick, and I'll make cutouts in the escutcheons to suit the TFT display and the buttons, etc. Very much like I've done on my Mark IV transceiver. Here's an example of the escutcheons I put on my Mark IV transceiver. They're aluminium, 1/4 inch thick aluminium. Then they had roughly about 6 coats of heavy duty black paint, the sort of paint that's used for painting motors in motor vehicles that can withstand a lot of heat. I find that paint's very durable and it's hard to scratch, and several coats of that makes the escutcheon quite durable. Normally aluminium doesn't take to paint very well, but the particular paint I'm used in the automobile industry for painting engines seems to work quite well, and you can buy them at the auto supply shops. The labels will be similar. They will be produced in the same way I've produced the labels for this particular rig. It'll be printed on an inkjet printer as if they're a photograph. The position of the dials and all that's all done on a graphics program on the computer. Once we have located all the knobs, we have a template. We then use the template to drill the holes in a blank piece of aluminium material. We then compare the template with the holes, make sure everything's correct, do any small corrections, and then print. In this particular case, it's one complete print. It's an A4 sheet on high quality gloss photo paper, and then that photo paper is then laminated with a silver lamination, which you can buy, a silver pouch, and it gives it quite a nice appearance, very durable surface because of the lamination. Sometimes it takes several goes to get that right. You want to make sure there are no bubbles or any imperfections, but once you've done that, it looks quite neat. and not very expensive to produce.